Okay, so thank you everyone. Today I want to talk about enhancing team performance from developer experience, or addressing the developer experience to improve the performance of the overall team. And I will get into the details of what I think when I say developer experience and how any of us as individual contributors can affect the overall performance of the team. Just a quick background before I start. As Ivana mentioned, I'm co-founder of Adiva. I am an engineer at heart as well, so I always want to kind of keep connected to tech through talks like this and researching about performance, productivity, and things that matter to both business side and engineer side. And the talk will be kind of focused on the developer perspective, but still at the intersection between, what matters to the product, the business, and what matters to us as developers. To start with, I want to go with a quick ideas of what affects team performance. I've been speaking with a lot of people lately, not only individual contributors, but also engineering managers, leaders at different levels of the company. People have different perspectives of what affects team performance, and we had a case recently with some researches or articles that came out about measuring performance and focusing on aspects that don't matter to developers and can't really affect or improve the performance of developers. And on the other side, we have something like developer experience and things we can all relate to impact the performance of the team. So when I spoke with all of these people, some of the biggest things that came up were shifting project requirements, lack of big picture, context switching, accurate planning, maintaining quality. And from developer perspective, all of these contribute to something that's called bad code, and that most of us have dealt with at some point in our careers. And that's the thing that I want to discuss today. So how does bad code affect the experience of each of us as developers? And then how does that experience affect the overall performance of the team? Because it doesn't matter only to you as how you spend your day and how interesting your work is and how willing you are to explore further in what you're working, but also how fast you can navigate through the code, how easy it is to extend it, to maintain it. It affects the whole performance of your team. So how can we improve the developer experience to enhance the team performance? The first thing that I want to talk about is based on solid design principles, which are kind of close to my heart and something that I believe can affect a lot how you design your code, how you think about extendability, maintainability, and affect the developer experience overall. And to discuss this, I want to explore a real-life example just to make it easier to follow. This is part of Adiva's platform, the part where under account settings you can manage payment details, so you can easily switch between different options. And so over here we have Payoneer and wire transfer as current options, fairly simple. This can be very easily implemented with a simple condition in the controller. Everything would work smoothly. What happens, and for a platform like ours, it's very important to enable various options for future scenarios, because there are a lot of payment providers, there are a lot of different conditions, people use different things, so we want to be able to extend. The thing here is, how can we easily extend this with additional payment options that will be available to the users without affecting the code too much and without breaking existing functionality? And together with all of that, how can we do that fast so that the whole team can be productive instead of just going to the old code and adding new things all of the time, and then when we go back we can't figure out what we did 2 months ago. So the first step is to write code that's easy to extend and maintain, and for this I will go through the solid design principles in practice. Under the assumption that we have a clean slate. So we can decide how we design our code. We start with the steps that we want to take that we think are most relevant in this scenario. The first one is to organize for readability and easy navigation. So when it comes to developer experience, to maintaining code bases, to extending them later on, a very important thing is how you organize them and how easy it is to read through it, to understand what a method does, to understand where you can find what you're looking for. And scenarios here are like, you work with a legacy code, you don't know what it does, it takes weeks to read through the code and only 2 minutes to implement the functionality later on. Another scenario is when you work with large code bases, you fix a bug in one place, then you introduce several other bugs elsewhere in the code because the code is not designed in a way that you can easily understand what it does, and it doesn't reuse the same implementation so that it can easily break when you change things. What does this mean in practice or in specific solid terms? I start with the interface segregation principle, the I solid, even though that one is fourth in line, because it makes things much simpler to understand on how we structure the code and how we design the classes and interfaces we have. The interface segregation principle states that we should never depend on things that we don't use. So all of the interfaces that we have should be simple, small, specific, and clearly define their role, so clearly explain what they do. And the purpose of this is to write code where everything is structured properly, that we have small interfaces that are self-explanatory, and we always know, we can always easily read through the code, we always know what each part of our code does, and that makes it much better, much easier to navigate through it. So this is how the code would look like, and I'm using a very simple structure here just to make it more easy to follow. In reality, this would be more complex. The thing that we have here is starting with the payment options interface that will define, it will be the contract, as it's called usually in Laravel, of how we define the classes later on. So what are the functions that we are going to implement, what are the functionality that we want all of these classes to have. In this payment options interface, we have functions like get fields, store, delete, and make primary. These are the things that we want to be able to work with for all of the methods that we have. So for example, for Payoneer, get fields would return all of the fields that we need to enter when saving the payment details. The store would be storing the details. Delete is for deleting, make primary is self-descriptive. And then to implement the current version of the functionality that we have this wire class with the same methods that are implemented. Again, for simplicity, I'm just outlining it here. We don't go into too many details on each of those. And we have the Payoneer class, which again implements all of the methods that we need so that we can easily go between the two. And first, let's stick to this initial principle, the interface segregation. They're separated in classes and covered by an interface that clearly describes what we need to handle in this case. So payment options only handles the management of the payment options. If we have processing of payments, which we will do, but elsewhere, we don't connect that one with the same interface. If we have something else that connects to payments, again, it can be a separate interface because we want things to be organized in more specific ways that exactly describe what they handle. Now the second step from here would be to decouple the code, and over here we're talking about single responsibility principle. The nice thing about starting with interface segregation and then going to kind of organically single responsibility principle is that the interface segregation actually creates that structure for us where we need to have the small simple classes. So let's go into the details and we can see in the code better. Based on the single responsibility principle, every class should have only one responsibility and only one reason to change. And then that means small and more specific classes with specific names that exactly describe this responsibility. So for the wire class, we have this class describes that we are managing wire payments. It implements the payment option interface. So the interface itself kind of makes us have these smaller and more specific classes. Again, we can go around it, but it's a great start. And then when we talk about only one responsibility, only one reason to change, single responsibility principle is the the most misused, let's call it like that, principle in Solid, because people often tend to fragment the code too much and go into too many small classes that do too many specific things, like update, user updater or user creator, and have all of these small methods that can be grouped in a different way. Now, I'm not talking that there shouldn't be scenarios where we organize our code in this way. My point is that oftentimes when we think single responsibility principle, it's very easy to go too deep into fragmentation, and that can cause code that is much harder to use and much harder to read through and understand. So if you catch yourself that you're introducing more complexity than you're actually solving, that's a sign that you've done it, you've overdone it. So we need to reconsider what a responsibility is. There was a very interesting example over here on Stack Overflow. There was some user asking, how can I refactor away from single responsibility principle? And when you read it, it's kind of a sign that you are there's something wrong with it, basically. A principle should make our lives easier, not harder, and if I need to refactor away from Solid, that means that it's either my code is too simple and I don't need to use this, or I have exaggerated with it and I need to rethink the structure. In our case, single responsibility, I want to illustrate it with kind of going into more specifics about how the methods would be implemented. So let's say the store method under any of our payment methods, we have a simple try catch. I'm using the get fields. Is my cursor visible? Okay. I'm using the get fields method here to dynamically pull all of the fields that I need for the payment method that has been chosen, and then just iterating through all of those, setting up the details that I want to save. And I'm using the connection with the user model I have to save this in the database. And this is a violation of this single responsibility principle, and a sign that I need to do something else here to separate it or decouple this code so that I can handle it elsewhere and have this class serve more like a service class, which can handle the business logic, and then separate the database logic elsewhere in a repository class that will be responsible for the database. Again, when we talk about code, the most important thing is for all of these design choices to make your life easier. So if separating this causes more complexity than it actually solves, using Laravel's models is a very simple way to implement certain functionality, and it's okay to use it. It's not like you always need to implement repositories or any design patterns. It always depends on the context of the project, but if we're talking about complex code that should scale and where you need to think about extending it, and when you know that you will need to extend it in the future, like it is in our case, then it's definitely worth investing more time upfront to design your code in a way that will make it easier to extend it later. So how this changes now with a single responsibility, we have this repository, and I will come back to this later. For now, it's just initializing my wire repository and then using it here to save the details. So now it's a simple change. Code-wise, it doesn't change a lot because we have the same amount of lines of code and the same complexity of the method, but in real life this would likely be a much more complex method where you need to navigate through various scenarios, and a change like this would introduce a lot less complexity in terms of maintenance and extending the code later. Now the third step would be to plan for future changes. Again, if you are certain that you need future changes, definitely worth investing time in this. If not, if the project is simple, KISS is the best principle to rely on. We have list of substitution principle. So the purpose of this principle is to always be able to substitute classes that implement the same interface. In our case, we have the payment option interface, we have the wire and pioneer classes. If we don't comply with the list of substitution principle, which states that we can easily replace any class with any other class that implements that interface without breaking the program, then we won't be able to do any of these scalable actions that we want to take. So the simplest thing, ListCode has a very complex definition if you look it up on Google, but it's much simpler than how it's formulated. So this is like exactly swapping between implementations to easily change the functionality as needed. So in simpler terms, we want to implement the methods properly and return the results that the program expects. So in the interfaces, we define what methods we have. We can do type hints to further define the outputs, but if we're not mindful about the response of all of these methods, so if we don't return what is exactly expected, then it will be still very easy to break the program when we swap implementations. Just in practice, very simple to grasp. That getFields method that I mentioned, in reality this would be a call to the database in our repository class, getting all of the fields that are stored somehow, but just for simplicity I created this simple method over here because it will make it much easier for us to follow. And let's say for a wire we have an array with a lot of a lot of objects structured in this way. We have a name, type, label, whether it's required or not, and the style for all of these objects which are supposed to represent the fields. And then I'm using use again for simplicity. In reality this might be an API or whatever the code is structured. And we have something like this. So going through the fields, checking the style, actually using the style just to ensure the layout is properly set up. Then going through the options to display the options and so on. What matters here for us is that our getFields method over here returns the same structure for all of these objects. If I have something of this format here and then something else in the rest, that might break the program because it's different than what's expected. We can't cover this with the interface contract because it's not possible. We should be mindful about how to implement it and also cover with tests so that we can be sure that all of the classes that implement our interface return the exactly expected results so that they can be easily interchangeably used later on. So let's see what happens. For example, our Pioneer class has different fields. If you remember the screenshots that we started with, for wire we have a complexity, multiple fields that need to be entered, payment details, bank details and so on. For Pioneer it's a single field email address. And because it's a single field, it's likely to just omit the style because I don't need to style this, it will take the default, it will be displayed accordingly, it's a single field so it's okay. Now, if we do something like this, then the program would break immediately because it's expecting something that we are not returning to it. So this is ListCode substitution principle in practice. We need to be mindful about what our program expects. We need to consider that when designing the code, and we need to take accountability of the quality because in traditional teams, it's a common practice to just do the basic implementation and then leave the rest to QA. Especially if you're not writing automated tests, it's very easy to say, okay, this was my job and now QA is responsible to test all of the scenarios. And it's very likely that in that traditional setup, the program would break like this because you have a lot of fields, a lot of options. And again, this is a simple example. In reality, it might be much more complex. But it's very easy for the program to break if we don't get that part of the quality and mindfulness of what the program expects. So apart from planning for the output, for the result, writing tests for it, if it's not part of the process in your current company, then just whether try to advocate for it or try to focus on the manual part more, but still very important to take on that role for quality as developers. And then if that is done properly, we could easily interchangeably use these classes, and we'll see in a bit how. Now the fourth thing is add, don't change. What this means is that we want to be able to extend our code by adding new code instead of changing existing one. And this is open-close principle in Solid. So what this means is it's often the most confusing one because of the name, I guess, but it's fairly simple when you grasp it. The open-close principle is basically explaining using code in a way of using a package or using a library, where we have a piece of code that is well tested and hardly ever changed, and that we rely on it all the time. We work with the rest of the code that gets changed most of the time by adding new code instead of changing the logic inside the existing code. And what happens, for example, with the packages we use? They are used by a ton of people, they get tested a lot, they get more stable over time because they're never changed, but they are tested all the time. We want to achieve that with the core of our software. We want to have the core of our software stay with the same structure without changing it too often, so that we can test it with every other iteration, and then whenever we need new functionality, we just add it on top of it, just like we would over a library or over a package. That's the gist of the open-close principle. Basically, our code should be open for extension, closed for modification, meaning that we need to extend our app with additional functionality without having to constantly change the existing code. And let's say now a simple example again. Our controller maybe looks something like this. We have checking the request type. Now, what has the user entered? If it's wire, we are making an instance of the wire class. Otherwise, an instance of the Payoneer class, and just store it. First, this violates the single responsibility principle because the controller knows a lot about the background implementation. And in addition to that, we'll get to it in a bit, the dependency inversion principle. Again, we need to rely, the controller or the high-level modules shouldn't depend too heavily on the implementation of the low-level modules. So we have a way to improve this with some additional restructure. But I want to go into the dependency inversion principle quickly first, because that covers these parts well. What the dependency inversion principle states is that our high-level modules shouldn't depend on low-level modules, both should depend on abstractions. And what this means is that in practice, we should replace all of the dependencies on concrete classes with dependencies on interfaces. Now, the goal of this dependency inversion principle is that if something changes, like for example, if we depend on the wire class and use it everywhere in the code, if we want to change something with it, we need to change it everywhere. If we depend on an interface, the payment option interface, then whenever we need to change something, it changes in a single place. We can add a new class that implements the same interface. We can add new code without breaking the existing one. Some more real-life, not real-life, more kind of visual example that always goes with dependency inversion principle is like electricity, for example, in your homes. To connect your laptop to electricity, you don't need to know the wiring or how things work behind the wall. You just need to know that you can rely on this socket over here and everything works smoothly. When we work on code that should scale, that's the goal that we have. So our controller needs to know that it can rely on something back there that will do the job. How it does the job, it doesn't matter. So this is the thing that we want to achieve over here. And now I will start with a factory here. So what I want to do is isolate this part of creating an instance from the controller, this part over here. So I don't want the controller to care about this. I don't want the controller to know what does which part based on the user input. I want this to be abstracted enough so that I can just rely on this factory and the factory will do everything for me. So basically the factory pattern just creates an instance of the proper class based on the input that we give it. And what happens here, I have this create payment option method. Based on the type that I receive from the user, I just create the proper instance and return it. And then we can have a service like this that depends on our payment option interface, so abstracting that part depending on the abstraction, not the concrete implementation. And this payment service is what the controller will use instead of relying on the specific class for Wire or Payoneer or later on Wise, whatever we want to implement in the process. So this is how this would change our code. Basically, we have this payment options factory that creates the appropriate payment option based on the type that we give it. Now this is multiple screenshots, and this should come from the request. Basically get the type from the request and then instantiate the proper class based on it. Then use the payment service to send the concrete implementation. Now the payment service doesn't know what it will get as long as it implements the right interface. The payment service knows that it has a payment option it can rely on. It does all of the job that I wanted to do, how it's implemented, and what the concrete implementation is in the background, it doesn't matter. So what happens here, our payment service is returning the appropriate payment service here, and then I just call the store method and everything works out of the box. So what this would mean here is that we can easily add functionality by adding new code instead of changing existing one. And what we spoke about, having the core of our system become resilient, reduce the number of bugs because the code is tested well enough and long enough and changed hardly ever. And all of the solid principles kind of work together. When you talk about open-close principle, it's like this is the sole purpose of the open-close principle. But if we don't do the dependency inversion, if we don't do list-off, if we don't do the rest, then we won't be able to achieve this. In our example with the payment options, now if I want to add Wise, for example, as a payment option, or Revolut, or whatever the trend is at the moment, I can easily do that just by adding another class that would implement my payment option interface, add a few lines of code in the factory that will say, okay, if the type is Wise, then return an instance of this class, and then create a repository potentially for handling the Wise payments. We could possibly expand this by abstracting it further on without having different repositories if our database is flexible enough, but let's not complicate it that far. The most important thing is that I don't need to touch my controller, I don't need to touch parts of the code that could easily break the whole system. I just add new code and then everything works out of the box. And this is kind of my mantra when it comes to Solid. It has become a saying that I love to share everywhere when I talk about this. Solid is your tool, it's not your goal. So when design patterns, design principles, anything really that you use, because the goal is not to achieve it, it's to use it to achieve code that's easier to scale, easier to maintain, to extend. And if we, the examples that we mentioned in the beginning, single responsibility principle, if we go too far to implement it, it might be a problem. And the part with the repositories, if we go too far and add repositories to a very simple project, again, it will introduce a lot more complexity than it solves. So always keep the context of the project in mind, always keep the needs of the team and how you want to extend further from that point, and have that as a base to decide on the design and everything that you use in your code. Now, we talked about starting from a clean slate, and that's all good. If we have the ability to design our code in the proper way, we know all of this, we would likely do it. How about dealing with code that's not at that early stage, so we don't get to make the design decisions? We just inherit something, and oftentimes we inherit it from ourselves. So we've done bad design decisions in the past, and now we need to deal with it. The problem with legacy code is that we often approach it with a mindset that it's bad and that we need to change it. So you always want to refactor legacy. You don't want to rely on the methods that exist because everything is too coupled together, too complex, and it kind of forces you to write code that's also bad because the code is initially bad. What we want to do here is work with the code, not against it. So don't try, because we will never have time to refactor legacy. This is code that is, and it's valuable for the business, so we don't want to do it. It has been on the market for too long, it has been tested well enough. There are some pieces of the legacy code that haven't been touched in years, but are well tested. So this is kind of our open-close in a different scenario. Basically, we don't want to touch and change that code because it works and it's fine the way it works. What we want to do is to use the code that we have in a way that we can write good code on top of it, but not change the code that is good enough so that it can continue to work. There are two techniques that I want to mention here. The first one is the sprout technique for managing legacy code. This person knows a lot about what I'm talking now. The sprout technique, what it says is that we need to write the code for the needed change outside of the legacy code base. So basically, we have the legacy code base that does what it does. It's okay. We need to write the code that we want to add outside of it so that we don't change what already works. And we can also write code that is good and follows all of the good practices that we have. We test it, so we follow all of the good design principles, all of the good practices for testing and everything that we have for all of the new code that we write. Basically treat the new code just like this clean slate scenario. We can do whatever we want with it, so we stick with certain good practices. And then we call the code from the legacy code, the new code that we write from the legacy code. So for example, if we have something like this, again, very simple, just to make it easy to follow, but likely this process wire payment is another method that calls another method and another method, and it's all very coupled together code that's hard to navigate through. What we want to do here is, if we want to add an additional method, and now I'm going into processing just to make it, it's not about adding a new payment option, it's more about how I process the code, the payment, and what I need to process it. For example, at Adiva we have a referral program for everyone that introduces people to join our network, and they get some referral bonus with every payment. So when we process the payments, we, over here in this logic, we check whether it's wire or something else, because right now we have two methods, a very common practice in old code that's not well structured. And what we do here, we get the amount, we get all the details, process the wire payment, and something happens. Now I want to add the functionality to deduct some part, or to actually add a part to the amount, so that this person would receive something extra. What happens is, and I deducted it here for some reason, but it should be a plus. Basically, I want to increase my amount with the additional amount that I calculate based on the referral service. And you will notice here that I have this separate service here for referrals. That's likely something new. This service is a service that I create that follows all of the practices that we described earlier. Something similar to that payment service that we went through. So a separate class that is responsible for the business logic of referrals. It calculates the bonus based on the user, the amount, all of the details that are necessary. And then this would return the appropriate amount to add to this and implement the payment later on. The only change that we do in this legacy function is that we adjust the amount somehow. It's very unlikely for this to break if this over here doesn't break. So the goal here is for the new code that we create with this referral service to be well written, to follow good practices, to be tested and everything, so that we can ensure that when we call it here, it will return the appropriate result and everything else will work smoothly. We don't touch the rest of the legacy code, we don't break anything else within it, it's just adding something before the rest of the code executes. And the second technique, again, for working with legacy is the wrap technique. So this one does a slightly different job, but again, the main purpose is not to change what already works, but to add on top of it. Remove all the code from the existing method and wrap it in a new one. That's the first step. So instead of this process payment method, we will create a new process payment legacy, for example, or whatever we want to call it. And just copy everything that we have over here, paste it to this new method. Then we will call the new method from the old one and add all the needed changes before or after the call to the new method, to the new method, to the legacy code. This is how that would look like in practice. So basically, we copy everything that we have and place it in something called process payment legacy. And then we have the process payment. It's important that this method has the same name as the initial legacy method, because this will be called from everywhere in the application. So instead of calling the legacy code, now we are calling the new code that we have created. Again, we try to test it. This one only. This can be mocked in the test. And then do what we want to do with the amount, call the rest of call the legacy method, and do something else. This is a good practice if we want to maybe do something else after this is called, like adapt the response and return something to the program. So that's the difference between this and the Sprout technique, but essentially they both do the same thing. Write the good code elsewhere, test it, follow the good practices, and just add it on top of the legacy code, so the legacy code can stay well tested and not change as much. And this is the other thing that I usually want to mention when I talk about legacy. Legacy code is valuable code, especially for the business, for the product. Legacy code is something that has been out there for a while, is doing its job, users are using it, it works as expected, and whenever it works as expected, we don't want to touch it, we don't want to break it, we just want to improve it and create new code on top of it that's good and that follows the best practices that we have. That's all I have for today, thank you.
Thank you, Kata. That was very insightful. We have a couple of minutes for any questions you want to ask, and then after that we can head upstairs for some refreshments and a 10-minute break, okay? Everybody shy? Or was it very on point?
Let's say you have a legacy code and you want to refactor it. How do you communicate that with the team? So how do you propose and convince everyone else that this is the correct way?
Meaning the technical people in the team to know that this is the good structure that we need to follow?
What's your experience with that?
Most of the time the issue are the managers, so I didn't expect the question to go from this angle. I guess it's important to discuss it with the team if someone else has a different approach or different opinion of what needs to be done. For example, we have had the experience with over-engineering stuff, like what I explained here with the factories and everything. We wanted to connect GitHub and potentially GitLab and other providers to kind of have these details on the user profiles, pull everything automatically and so on. And it was a test project that we wanted to start clean and to use all of the good practices and everything. So we created adapters, we created factories, we created everything, and then we ended up not using the code at all. So that's also a very important pitfall, because if you have people on your team, for example, opting in for models and you are forcing repositories, what's the reason for the repository? Is it actually solving a problem, or is it only because you want the code to be structured theoretically in the best possible way? If it's the latter, then it's likely not important to focus your time on, and you could create much more value with something else. But if the restructure would save time later on and it would make it easier to extend it, and you know that you will need to extend it and so on, then definitely discuss it. So it's very tricky because you need the context to make the decision, but it's important to hear out the other opinion and see whether it makes sense and why they don't want to go for refactoring. A lot of times people don't like refactoring because it seems boring. If that's the case, then you need a different approach, and you need to show them why it's important and how it will make their life easier and so on. But now from the business perspective and leadership perspective, that role that I have been in the past, it's very important when you communicate all of this to focus on the actual impact, not on, okay, our code would look better and it would be easier and so on, but on how it makes my life easier and what can I do better now if I invest my time into this. Because if I'm bored with the refactoring tasks, I don't want to do it. But if I know that the refactoring would cause something else to be easier in the future, or it solves an immediate pain point that I have longer down the road, then definitely something I want to invest in.
Any other question? Kat, I guess we're on point. No questions asked.
Thank you.
Okay, thank you guys. So we can head up upstairs. There are some refreshments. We can network a bit, have a break, and then I will see you back here in 10 minutes. Okay?